All right, Abby, so let me see if I can help you out with this question. So here's our chemical equation, and I'm gonna start with the first part of this problem. So let me see, I'm gonna grab a marker. Okay. So we know our equation is, I'm gonna write it up here. We have delta H of the reaction is equal to the sum of the moles of the products times delta H of the products minus, the sum of the moles on the reactant side times delta H of the reactants. Okay, so that's what we're talking about here, and that's where I'm going to start, is with that delta H equation that I wrote terribly. It's fine. So we're going to start with products on this side of the equation. So we have, I write it a little bit differently. If you don't like it that way, that's totally fine with me. You can use the way that it was shown in the video. Not a big deal at all. So I use brackets to separate my two sides of the equation. So starting with products, we have 4 times for the NO2, which is 33.18, plus 6, and on the chart it said negative 285.83. Close it, and close my brackets because I'm done with the products. Now I'm going to subtract reactants. Open my brackets again, and we're going to have 4 times negative 46.11. And then, as you know, this is an element, so it's 0. 7 times 0 is 0, so I'm not even going to bother writing it. And I'm going to close my brackets. Okay. Where did I put my calculator? Here it is. So whenever I put this in my calculator, 4 times 33.18 plus 6 times negative 285.83, subtract 4 times negative 46.11. All right, good stuff. So we have and the units here are kilojoules per mole. Okay, so that was the first part of the equation, or the first part of the problem. Now the second part says, how much heat will be released if 22.4 grams of ammonia is burned? Now the way that she did it in the video is a little bit out of order than how I would probably explain it, so let me explain it my way. We know, so this would be the question 2. We know we have 22.4 grams of ammonia. Okay, but as you know, we use moles. This N number of moles, that's what we're talking about. We haven't talked about grams at all. So your first step is you're gonna go from grams to moles. Okay, so put what I know over 1, and I know I have 22.4 grams of ammonia. Okay, now to get rid of grams, I'm gonna use molar mass, and that is, I believe, 17.03 grams of ammonia. And what do we want? We want moles, so moles are gonna go up top. Okay, so grams of ammonia are gone. Now we have moles. Perfect, so all we have to do is divide. So 22.4 divided by 17.03 will give us 1.31 moles of ammonia. Fantastic, so that was step 1. Now step 2 is, it says how much heat? Moles is not heat, so we gotta go from moles to heat. And that's kilojoules, okay? So I'm going to use this number because this is our known value. So that's 1.31 moles. Okay. Now I want to get rid of moles. And as you remember up here, it's kilojoules per 1 mole. So we want to get rid of moles. Goodbye, moles. You're trash. Okay. Then I'm going to put what I want up top. And using this, I want kilojoules. We're going from moles to kilojoules. This is what I want. So I'm going to put this number up top. Because it's saying it's burning ammonia. This was the equation for the burning of ammonia. Oops, why did I put a decimal point right there? My bad. And I forgot my negative sign. Goodness gracious, negative 1397.82 kilojoules. Okay, and then all you gotta do is multiply. So, times negative 1397.82. There we go. We have negative, oops, I accidentally pressed the button twice, so just ignore that last little part. I don't know why that popped up. Negative 1838.58. And that is how much heat. There you go. Hope that helps.